Dear learners, we shall be starting with the lectures on artificial intelligence and business law, an emerging area which has aroused a lot of interest amongst entrepreneurs, technology experts, law regulators, and laypersons alike. Since there are several aspects of AI that we are going to cover here, I'll be approaching this topic in multiple parts. So, in this specific part, we'll be talking specifically about what AI is and how to understand the various aspects of AI. So, my name is Kaif Siddiqui, and I'm your course instructor for this topic from Nasir University of Law, Hyderabad. So we shall begin with the very idea of defining AI. What do you mean when we talk about AI? So AI refers to the simulation of human intelligence processes by machines, especially computer systems. Now, what do we mean by simulation of human intelligence processes? So this is basically a field that is essentially dedicated to making computers mimic our cognitive abilities, and AI systems strive to replicate the way that humans think, the way that humans learn, the way that humans make decisions. We are basically teaching computers to process information in the same way that a human brain does. So in this context, the primary goal is to create systems that can reason, learn, perceive, and act to solve certain problems. So those problems can be widely defined. So AI is used in a wide variety of fields. There are different kinds of technologies that are called AI, which we'll just get into in a minute. So these core abilities, the ability to reason, how does a human being reason? How does a human being carry out his processes of learning, perceiving certain things, perceiving the environment, perceiving problems, perceiving concepts, and acting to solve problems? So basically, putting together a system of steps to achieving specific goals. So these core abilities are what define intelligence. These core abilities are what we consider to be intelligence. Even though the term intelligence itself has a lot of different meanings, a lot of different connotations. So, the primary goal when we are talking about AI is to create systems that can reason, that can learn, that can perceive, and that can act to solve problems and achieve specific goals. So, these core abilities are what define true intelligence in a machine. So, successfully developed AI can handle a lot of complex tasks, ranging from driving a car to diagnosing medical conditions. Therefore, the goal is to build machines that are very flexible and adaptive and not just programmed to do one task. So the core behind AI, the core idea behind AI is to make machines that can act autonomously to pursue different goals, and that those systems don't need to be taught how to do certain things. They can figure it out based on the data that is given to them. So of course, there's an issue when we come to the term AI. Of today, due to marketing, many unrelated technologies are often not clubbed under AI. So what is meant here is this. Imagine if instead of using terms such as bus, train, or car, we simply use the term vehicle to refer to all means of transportation. So some person says, I am going to the store through my vehicle. I am going to Delhi on my vehicle. I am going to London through a vehicle. So we don't know what vehicle is being talked about. We don't know if it's a plane, if it's a car, if it's a train. This necessary information that is needed to understand something fully is not existent here. So something similar is going on with the term AI. So which is used to refer to so many different technologies that when we use it in sentences, it simply does not convey any kind of useful meaning, right? So a lot of it is therefore more marketing and hype, which can be misleading. So facial recognition technologies are fundamentally different, for example, from your generative AI chatbots, so like ChatGPT. So that technology that is behind ChatGPT is not the same as the technology behind facial recognition systems, right? So there is a difference between these technologies. They may be using some certain similar technological systems underneath, but ultimately the purpose these technologies serve is different. They are used in different ways. The problems that they have are different, and compare these two to maybe something like autopilot systems in planes, right? So all these are different systems and they are all called AI. So we need to be very careful about the vocabulary that we are using when we talk about AI. The choice of vocabulary matters. So what is the history of AI? Where did AI come from? So this concept was formally introduced at the Dartmouth workshop in 1956, which is considered as the birth of AI as a field. So this was a landmark event. This was organized in the United States of America in the 1950s, and this was an event where a lot of brilliant minds came together to propose the idea of building machines that could reason like humans. So the term artificial intelligence was given to, it was a new term that had come up, and that new term must have caused a lot of discussion at that time, because at that time there was no such thing as AI. So This point marked the moment where artificial intelligence was named and established as a dedicated area of study, launching decades of research. So, early AI was very different from the AI that we understand now. So, it focused more on symbolic reasoning, which is basically teaching it certain symbols, certain things, certain meanings of words. It is a little too complex to get into right now, but suffice to say, right now, this approach led to success at that time, but this was short lived, and eventually there were periods of ups and downs where AI was not able to evolve further. People were not able to make technological breakthroughs, so they ultimately struggled because of the real world complexity that comes with solving real world problems, right? So early AI focused on symbolic reasoning, leading to initial success but ultimately struggling with real world complexity and massive data. Over time, however, the development of AI went through a lot of ups and downs, sometimes due to periods where funding was short and sometimes due to technological limitations. However, today, the current boom, the current hype cycle, the current excitement about AI, that can be traced back to roughly the 2000s, and this is driven by vast amounts of data, cheaper computational power, and the advancement in deep learning algorithms. So now, what are deep learning algorithms? We'll come to it in a minute, but basically these three aspects: advancement in technology, advancements in the power resources that were available, and the amounts of data that were now available to researchers, was what led to the AI boom. So these three elements, they created a perfect storm for rapid progress. The ability to process massive data sets on a more efficient form of hardware is what has made complex modern AI systems possible. So we hear the term machine learning often mentioned in relation to AI. But the question is, what do we understand when we say machine learning? So machine learning is basically the primary method where AI systems learn from data instead of being explicitly programmed with every rule. So the fundamental concept behind machine learning is that you teach a computer to identify patterns and to make decisions by feeding it vast amounts of data, and this data will be labeled or unlabeled. We'll come to that later. But this data is then used by the AI system. It is used by the machine learning algorithm. And what is an algorithm? Algorithm is a set of instructions to do certain things certain ways. If this happens, then this happens. If this happens, then this happens. So it's a step of instructions, a series of steps. So this ability to learn from examples is what makes machine learning so powerful, because it does not need to be taught the rules manually. It does not need to be told you do this. It needs to be given the data and it will figure it out itself. It will figure out how to do things once you give it the data. So that is machine learning in a very simplified form. So this ability to learn from examples is what makes machine learning so powerful for handling complex real world problems, and it is how algorithms get better over time without being manually rewritten. So, of course, with technological advancement, you might need to update your machine learning algorithms, but for the most part, they're able to learn on their own. They get better and better over time by training themselves. So, then specifically, neural networks are what power deep learning. Deep learning is basically a subset of machine learning, and in deep learning, the attempt is to mimic the structure of the human brain. So the human brain has neurons which fire and transmit information, right? So just like that, there's a system in deep learning where there are nodes, and these nodes are used to transfer information. So information flows through these layers, and each layer processes the input data, and then these layered structures, there's layers of information flowing through these structures, and this allows the system to automatically discover complex patterns and relationships between different points in the data. So the deep in deep learning refers to the multiple hidden layers that process information sequentially, leading to high level processing. So essentially, the more layers that you have, the more abstract and complex the thing the network can recognize. But of course, all the algorithms would be useless without actual data to study and learn from. So now we come to talking about data specifically. What is data? What is a data set? And how does data work in the machine learning algorithms? So how is data used by AI? Datasets are the foundational collections of structured or unstructured information, that is, images, text, numbers, all kinds of information. And these sets of information are used to train machine learning models. So, the way you train a machine learning model depends on the data you have. So, these datasets are like food for the AI. Without these data sets, the models cannot learn anything about the world. And it depends, the data set would have, and basically, whatever the data set is about, that is what the AI would learn. So, the data set represents the real world example that the AI uses to develop its patterns and decision making abilities. They serve as a historical record that teaches the AI how things really work. But you cannot just put together any random bunch of images or text or numbers and tell the AI you learn from this. No, even it might find something, but for the most part, data needs to have quality, quantity, and diversity. So the quality, quantity, and diversity of the data are the most critical factors determining the performance and the accuracy of the resulting AI model. Right. So so a large amount of low quality or biased data will result in a poor performing model. Conversely, well curated, diverse data is essential to create robust and reliable AI systems. But the whole task of collecting data, organizing it, cleaning it, making sure it does not contain any wrong information, that is a task that takes a lot of labor, a lot of effort, a lot of time, and a lot of computational and environmental resources. We'll come to this as well. So, this part is very important. So, flaws in the data set will make the AI permanently inaccurate. So if the data set is flawed, it does not contain certain valuable pieces of information that you need for an AI model, the AI model will be inaccurate. So the more time and effort you spend in your data set, the more time and effort you spend in cleaning data set, the better your AI model will perform. So flaws in this data, such as bias or incompleteness, are directly encoded into the model, leading to inaccurate outcomes. So there's a phrase that is used in this field that is garbage in, garbage out. You put in garbage, you will get garbage out. So this rule holds true even for the smartest algorithms. So, and what is labeling? Labeling is basically when you tag a particular piece of information with a particular point of data. So you want to train a machine learning model and you want to make it understand what an apple looks like. So you will give it tons of photos of fruits, but how will it know which fruit is an apple and which fruit is not an apple? So you'll have to manually point and add a tag on each photo of the apple so it identifies that this is apple, this is not apple. You will not tell it that an apple is red, that it will figure out itself, but you will need to give it that level of data. So you understand, if you don't give it enough data, and if for example other fruits and vegetables that are also red in color, if you don't give it enough data, and if you don't give it enough data that makes it understand it is a difference between an apple and a tomato, it will not understand that. So it will think that tomatoes are also apples because they are both red, because they look similar. So that is something that people who train AI, people who code in the data sets, they need to understand. But even as someone who is not directly working the data set, even as someone who is working with a completely trained AI model, often this might happen with businesses, companies, individuals. So even they need to understand that the data set that might have been used to train this AI model might be flawed. So you must never accept 100% that whatever an AI model says is 100% accurate. It can be inaccurate and it might be inaccurate in a lot of times. So this is all about how data is used by AI. So then we need to come to the next point, that is the very applications of AI. So there are lots and lots of applications of this whole branch of science and technology that is known as machine learning and deep learning, and we see them in the form of these applications. So all these are very different technologies. They might all use machine learning, but they're all different in terms of how we perceive and how we use them. And the issues that come up with all of these are also, they also might be different. So first we have virtual assistants and chatbots. So AI tools like Siri, Alexa, all of these use what is called as natural language processing. So they use natural language processing to understand spoken commands, answering questions, automating tasks. So chatbots provide instant 24/7 customer service and support. So if there is no person available on customer service, there can be a chatbot that can help you answer your queries, whatever queries they might be. So NLP is the technology that bridges the gap between human language and computer understanding. These systems dramatically improve user experience by allowing natural conversational interaction with machines. The goal is to make talking to a computer feel as intuitive as talking to a person. But this also brings up another question. How much of our systems do we want to be replaced completely with chatbots? Do we want that every smartphone interface, every website for every kind of service, booking flights, booking hospital appointments, booking any kind of service, do we really want every single service to have a chatbot? A human being would be preferred to a chatbot, and which are the situations in which a chatbot might be preferable to humans? That is an open question. So you might think that if it is possible for there to be any downsides as well. When computers began to talk exactly like humans, what did we lose? What happened to human conversations? What happened to human thought processes? This is something that one can endlessly debate. So it's an open question. Then we have recommendation systems. So now you see the difference between chatbots and recommendation systems. Chatbots are openly conversing with you, but recommendation systems are silently influencing what you see on these platforms. So there is no AI telling you that, see, I'm recommending you this. They might write at the top recommended for you, but there is no mention that there's machine learning, but it's just operating in the background. So there's a different use of AI compared to chatbots. So these systems are used by platforms like Netflix, Amazon, Spotify. They use machine learning to analyze your past behavior and preferences, offering personalized suggestions for movies, products, and music. So these systems are pattern detectors. They're highly sophisticated pattern detectors that can predict what you might like next. So prediction of the next thing is a very, very core part of a lot of AI technologies. So these things try to guess what you might want next so that customers can buy more, and then user engagement in sales could increase through personalized recommendations. So they are a core part of the modern digital economy. They work by comparing your taste with thousands of similar users. So you might be part of a group of users identified by the AI that all these people have the similar taste, so all of these people will recommended this thing. Now imagine the millions and billions of data points that this kind of analysis would take. So again, something to reflect on. But once again, it is also worth reflecting here as well on the larger impacts of algorithmic recommendation system on society, good impacts as well as bad impacts. So again, something for you to think about. So then we come to further applications. Another very important use of AI, again, this is also different from the previous examples. Search and navigation. So when you are searching something on something like Google Maps, AI algorithms are optimizing web search results, and they are providing real-time traffic and route suggestions in GPS apps like Google Maps using predictive modeling and data analysis. So for navigation, AI constantly analyzes massive streams of live data to forecast traffic jams and suggesting the fastest alternative routes. However, again, even here it's not just the map and geographical data. Even here, that might be also looking to predict certain things, prediction of actions, decisions, and so on. So they might want to know the place you would go to next, so they would recommend this place. This is the most frequently visited place. So in the context of mapping and navigation also, therefore, search engines will use AI to understand the intent behind your queries, not just the keywords, but your intent, thus giving you better results. And then one more very important example, facial and image recognition. So face ID, scan to unlock. These are used for unlocking smartphones, tagging photos on social media, and securing surveillance system via computer vision. So what is computer vision? So computer vision is a field that enables machines to see and to interpret visual information from the world. So as we have understood previously, through the use of machine learning, AI systems are trained to recognize patterns and features. So these patterns can also be expanded to images. So images, what are images? Images are collections of pixels, collections of visual information. So AI can also analyze those and make guesses on what the image is, just like we mentioned before with the example of the apples. So AI systems are trained to recognize patterns and features, allowing it to perform tasks like accurately identifying a specific face from millions of others. Once again, however, the scholars have researched around the world, facial recognition may not always be accurate, and this can have negative impacts if it is used in law enforcement contexts. So, from here on, we come to another important application, healthcare. So AI excels in diagnostic imaging, in drug discovery, in personalized medicine. It has an ability to process vast amounts of medical data rapidly, transforming patient care. In diagnostics, it acts as a powerful second opinion, spotting subtle signs of disease that a human might miss. This efficiency means that doctors can spend less time analyzing images and more time talking to patients. So some of the biggest AI breakthroughs have come in the medical field. And then finally, there's one more application that we will talk about, that is transportation and logistics. So AI is also the core technology behind autonomous vehicles, which include cars as well as drones. So autonomous vehicles use AI to perceive their environment, to make complex real-time decisions, and to navigate safely. So not just the mapping data, the geographical data outside your car, but even inside your car. If it's an autonomous car, if it's a self-driving car, then the technology might be using AI to. This technology promises to revolutionize logistics by optimizing routes and improving road safety overall. The real world is different from some prompts inside a chatbot menu. A chat GPT cannot do the same thing in the real world. It is a different technology, as I'm emphasizing once again. So these technologies that are used for transportation, they need to be capable of processing large volumes of data in real time. They need to process sensory input in milliseconds to react correctly on the road, because a split second error can mean loss of lives. So they must be able to take decisions immediately. This, however, also makes us question the level of autonomous inputs that we need in technologies like cars. So, in this particular area, scholars have suggested that it is always preferable to have humans working alongside AI-powered driving systems instead of, fully autonomous cars, because human decision making cannot be replaced, especially in moments like this. What if an AI maybe loses connection and you crash? And a human might be able to make a better decision at the very last minute compared to an AI. In certain cases, of course, the AI would also be able to do that, but at the end of the day, the question is, do we leave decision making, the final decision making, in the hands of the human or in the hands of the AI? That is again an open question. So this is also something that one needs to think about whenever we look at AI in various fields. So then we have to talk about the negative impacts of AI. So there are lots of very important points that one must look into here. The first point that we have to look at is job displacement. So extensive automation of routine, repetitive, and increasingly complex cognitive tasks threatens to displace workers in sectors like manufacturing, data entry, and even some white collar professions. So concerns about job displacement suggest that today's era requires societies to focus urgently on reskilling and education to prepare the workforce for new roles that complement rather than compete with AI. So we need to prepare for a world where repetitive tasks are largely done by machines, shifting human work to problem solving and creativity. At the same time, machines also might fail in certain tasks. Reports suggest that replacing human workers en masse might actually be detrimental to businesses. And this is very important from business law perspective as well. The effort and labor that might be required to fix errors and mistakes caused by AI might actually be much greater than the costs that are saved by AI. So if you are considering, like in a business context, replacing certain tasks, replacing certain workers with AI, one has to consider if it will be even worth it. Because even the most powerful generative AI models today, the models that generate text like images and text, even these models fail in a lot of tasks. So when these models are still failing despite being the most advanced, how can we make this sort of assumption that it is time to replace all workers in all sorts of jobs where there are routine tasks? And even the most simple sounding tasks, sometimes advanced AI systems might fail, and that might lead to billions and billions of dollars of losses. So we have to understand that sometimes replacing AI with workers might not be the efficiency gain that it seems to be. So that decision that must be taken with the utmost care and caution. And increase inequality is another very important aspect of this. So the benefits of AI primarily accrue to corporations and highly skilled workers who develop and manage the technology, potentially widening the gap between the rich and the poor. So the concentration of wealth and power could exacerbate economic disparities that already exist today. We must consider policies of AI that ensure that the economic gains from AI are distributed more broadly across society. And this is a very critical discussion about who owns the immense wealth that AI creates. If AI will lead to a creation of wealth, who will it most benefit? Presently, AI development is largely influenced by the most powerful technology corporations in the world, the big tech companies, so called, with the impacts being felt on society at large. Among other things, these impacts particularly occur in the form of environmental destruction, which we next move to. So the whole process of machine learning and labeling and generating an output, these have a lot of energy consumption the more powerful the model is. So training LLMs, large language models such as ChatGPT, which is one kind of AI that we talked about earlier, generative AI. So these systems require massive data centers. Data centers are basically huge facilities that are filled with hundreds and thousands of servers and computers all in one facility. Sometimes they're as big as several football fields. So they take up a lot of space, they consume a lot of energy, they need water for cooling. Most interestingly, the water that they use for cooling has to be clean water. If they use impure water, that might clog the pipes with dirt and the cooling process might get affected. So they emit a large amount of heat. They create a lot of environmental hazards because of this. They also cause air pollution and may also cause water pollution as well. So this is a big issue presently with the modern AI development systems. So this incredible computational demand is necessary for the AI to learn from its vast data sets. And as discussed earlier, the computational costs mean that only a few large companies can afford to build the most powerful models. So the industry must find ways to make sure the process becomes more green, or it might risk contributing heavily to climate change. Is something that's already happening. So this is an ongoing debate, and society, governments, companies, people, citizens are all debating right now whether the benefits of AI are worth the costs. The costs that include environmental harm, labor exploitation, and impacts on human minds, which is the topic that we'll move to next. So algorithmic bias. Algorithmic bias, AI systems trained on historical, biased or unrepresentative data can perpetuate and amplify societal biases in hiring, loan approvals, criminal justice, leading to unfair or discriminatory outcomes. So the issue is not the algorithm itself, but the flawed data it learns from. This might be true in many cases, it might not be true in other cases as well. This is therefore a major ongoing debate as society, governments, and companies all debate on whether the benefits of AI are worth the costs that include environmental harm, labor exploitation, and impacts on human minds. So then we come to a very, very important topic, algorithmic bias. So AI systems that are trained on historical, biased, or unrepresentative data can perpetuate and amplify societal biases, leading to unfair or discriminatory outcomes. The issue is not the algorithm, maybe. Algorithmic bias. AI systems that are trained on historical, biased, or unrepresentative data can perpetuate and amplify societal biases in hiring, loan approvals, criminal justice, leading to unfair or discriminatory outcomes. So, addressing this issue requires a careful auditing of training data and developing techniques to promote fairness. If the training data reflects an unfair history, the AI will simply learn to repeat that unfairness. And as we've discussed before, law enforcement is one area where the problem of biased datasets become much more serious. Because as one wrong decision made by an AI and relied upon by a law enforcement officer might ruin an innocent person's life. Also, the case in situations where people are not able to get loans or avail of government welfare schemes, which they depend on for their lives, right? So, because some AI system has tagged them as criminals or defaulters due to some issue, some error, something in the data set. So, it is very important to ensure that AI outputs are not taken as an unshakable truth. It is important to subject them to human supervision. Then, the issue of the lack of transparency. So what happens with AI system is that they're often so complex that even the creators cannot understand why a particular AI model is exhibiting a particular kind of behavior. This lack of accountability and explainability is a major hurdle in regulated industries. I believe troubleshoot or trust a system if we don't understand its underlying logic. We cannot expect to teach a system any kind of values or morality if that system doesn't seem to have any concept of morals. We don't know why AI is saying the thing it's saying. So this is a black box. This is called a black box. We don't know what's inside that black box. Even the creators can't figure it out. It's so complex. So this black box nature makes it incredibly difficult to understand why an AI makes a certain high stakes decision. So the higher the stakes are, the more one could lose if AI is not used carefully. So certain case studies now which will illustrate how AI not being properly deployed can lead to a lot of losses and a lot of harm to people as well as companies. So the first example is IBM's Watson. This was an AI platform that was aimed at revolutionizing healthcare through data analysis, but it was not enough and it faced a lot of criticism for its performance, for its accuracy, and challenges in implementation. And this project demonstrated that simply having advanced technology is not enough. An AI system needs highly curated data, clinical validation, especially in the case of the medical field, and seamless integration into existing medical workflows. The case showed that applying AI in a sensitive, complex field like medicine requires far more rigorous testing than any other application. Then we have Volkswagen's diesel emission scandal. Now this scandal involved Volkswagen, the car company, using AI algorithms to manipulate emissions testing results, and this led to regulatory fines and reputational damages. This scandal highlighted ethical concerns about the potential misuse of AI and how AI can be used to manipulate results used by corporations to evade regulatory scrutiny and to profit, basically. So, the misuse case showed that AI can be weaponized to actually deceive regulators and the public. And the incident sparked crucial conversations about AI governance and the need for clear legal liability when algorithms cause harm. And it's a reminder that advanced software can and will be designed to cheat the system. And another example that we have is Google's Bard example. So this involved Google being live on stage, Google employees trying out their chatbot and showing it off at a public event where it was being promoted, and they gave it a prompt and it returned an incorrect answer. And because of this live on stage incorrect answer, Google lost billions and billions just in that very moment. So that is also something one needs to be careful about. All these examples illustrating the same thing, that deploying AI is not trivial, it is something that needs to be taken very seriously. And then we have one last example, that is the example of Air Canada. So in 2022, the chatbot on Air Canada's website promised a bereavement fare to a passenger who was assured that he could book a full flight and then he would get a bereavement because he was traveling for his grandmother's funeral. However, he was not able to avail the reimbursement later on, and the company said that the chatbot did not represent company policy. The British Columbia Civil Resolution Tribunal rejected that argument, ruling that Air Canada had to pay him damages and tribunal fees. So this tribunal decision also set an important legal precedent that companies are legally responsible for the information provided by their customer facing system, just like a human had said it. So on this note, we come to the last point, that is AI and the human mind. So when a person is using AI, what are the positive and negative impacts? So the positive impacts include freeing humans from expending energy on mechanical tasks, freeing up mental resources for more complex or creative endeavors, and this will allow humans to focus on more strategic, more complex tasks, right? And this might enhance productivity and creativity. However, this requires very measured and very careful usage of AI. If one does not take care about this, they might fall into the other impacts of AI, that is, chatbots provide instant, fully formed answers. So, the negative impacts include chatbots allowing people to bypass the very idea of thinking. So, if you are regularly using a chatbot and you're regularly just letting that chatbot think for you, what is that doing to your mind? What is that doing to your mental muscles that are required for deep thought and complex analysis? We risk outsourcing our critical thinking, making us intellectually lazy if we don't actually practice those skills. Therefore, is that excessive reliance on AI, especially over tasks that are vital to developing young brains, poses a clear risk of cognitive degradation. However, when AI is used as an active collaborator, that is a tool that generates initial ideas, finds information, streamlines processes, but which requires the human user to critically evaluate, integrate, and verify the output, AI can actually be a cognitive amplifier instead of the opposite. Instead of cognitively degrading your critical thinking skills, it might amplify them. So that is a choice that one must make when utilizing AI in any sort of context. So we'll just summarize what we've gone through so far. The first topic that we talked about is what is AI. I'll just go to the very first slide. So we first talked about what artificial intelligence is. So we first talked about what AI is, what are the primary goals of AI, what is meant when we say AI, and due to marketing, many technologies are clubbed under AI, so the need to have a specific vocabulary. Then we talked about the brief history of AI and how it has evolved over time, and we talked about machine learning and neural networks. how AI systems learn from data instead of being explicitly programmed with every rule. And we talked about how data is used by AI, how the quality, quantity, diversity of data are the most critical factors determining the performance and energy of quantity and diversity of the data that are the most critical factors determining the accuracy and performance of any resulting AI model. Then we talked about different applications of AI, virtual assistants, chatbots, recommendation systems, search and navigation AI, healthcare, transportation, facial image recognition. So, and then we talked about the negative impacts of AI, so the displacement of jobs, the increase in inequality, the energy consumption, the large carbon and water footprint, algorithmic bias, discrimination, lack of transparency. And then we talked about some particular cases where companies face a lot of loss to reputation and face penalties due to their improper usage of AI. So, with this, we will move to the next topic, that is AI and business law. Thank you.